Okay guys, how are you? I hope all is fine, and I'm just doing a numerical based video on the concept which is reciprocating engine propeller combination. I have actually explained you all the concept in detail in a process of videos comprising of stages from 3 to 4 videos at least, and I have covered the topic in detail. And with the book that was actually written by Anderson Jr., actually I've covered or taken the same example, which is 3.2 from the course or textbook. So the example says the Cessna Model 310 twin engine propeller driven airplane is powered by two Continental, which is IO 520M engines rated at 285 horsepower each at 2700 RPM at sea level. Macaulay 3-blade propellers are used with a diameter of 6.27 feet. The maximum speed of the airplane at sea level is 238 miles per hour. Assume the performance of the propeller is given by the propeller efficiency curves in figure this, which now we have discussed the propeller efficiency curves with the three different type of the curves, and that the propellers is given and the propellers are variable pitch so as to obtain the maximum efficiency. Calculate the maximum horsepower available from the engine propeller combination at a sea level. Okay, so what we have actually know the engine propeller combination, so we have to derive the horsepower, which will be the maximum horsepower from our variable pitch orientation of the propeller, in which obviously the pilot can change the thrust by thereby changing the torque, and also we have the efficiency as well. But with the help of this data which is in front of us, we're going to derive the equation. So let's see how we can do it. We have for example, which is the ratio J, which is normally we're going to explain for the engine propeller combination, and it is the J is normally represented as, just to find the solution and also to get all the data right. What we have PA is equal to N of propeller, which is power. Okay, that is our equation. And also we have an equation which is like P of which normally is represented for the this propeller efficiency is also, we can actually explain it in terms of J, and we're going to explain in terms of ratio, which is normally represented as a ratio of free airstream velocity divided by N, which is the number of revolution, into the diameter of the propeller. Okay, so that is how you're going to have that ratio. So which is, this is revolutions per second, this is the diameter, okay, in feet you can say so, and velocity normally would be explained in kilometer per hour. So this is how that would be, that the units would be kilometer per hour, that would be revolution per second, and that would be in feet. Okay, so this explanation of J is when we say as a function of J, you can also have the power factor as well, and also you can have the efficiency obviously in terms of function of J, and that function of J can also be used. Normally we can say that function of that is normally the function of J. So we have to find J to put the values over here, and when we have got the values and we have got this value, we can able to calculate PA. That's so simple. Okay, so what we have got, first of all, the two engines with this obviously each, And first of all, we're going to calculate what we have. The velocity, the maximum speed of the airplane at sea level is, we have this is equal to 23 miles per hour, and when you're going to convert it into kilometer per hour, you just 1 mile is equal to 1.609 of kilometer, and when you have the velocity, that means 238 multiply by 1.609 would be what? 383 approx. That would be kilometer per hour approx. Okay, so when we have what revolutions, which is rpm, is 2700, and converting it into rps, 2700 divided by 60 would be 45 rps. And then we have what? Diameter. Diameter is normally represented as in feet, so the diameter is 6.27 feet is the diameter. Okay, this is how you're going to explain it. Let me have this. And 6.27 feet. And now putting the values, we have number of propellers are number of propellers are 3, and now we're going to calculate for 3 propellers. The diameter would be 6.27 into 3 would be 18.81 collectively. Okay, so that is each propeller. Now putting the values, and J is equal to what? Is J is equal to velocity, which is now equal to 38 of 3 kilometer per hour, divided by revolutions per second, 45 into diameter, which is 18.81. So the answer would be what? The whole answer would be equal to 0.45 per engine. Okay, but we have a number of engines is equal to 2, so J would be 0.45 into 2 is equal to 0.90. And when we going to have that value as a function of efficiency, that means that will also equal to 0.90. And we know that PA is equal to this into this, and when we have 0.9 and the power, which is engine, is 285 horsepower each, so that would be 285 into 2, we have 2 engines, so that means it would be 0.90 into 5 of 70 PA, and PA would be equal to 513 horse of power. Okay, so that is the equivalent answer. that you're going to calculate 513 of horsepower. PA is equal to 513 of horsepower. So this is the available power. Okay. So this is how you're going to calculate available power is equal to 513 of horsepower. And what is the condition for that? That calculate the maximum horsepower available from the engine propeller combination at sea level. So that is at sea level. Okay, so this is how you're going to have this answer, and I hope so that I have explained you the numerical as per the concept for the engine propeller combination. And I hope that you have explained. You can go through this example if you want to actually practice this by yourself, and you can go through the videos as well just for your clarification of what are the ideas and what are the basic concepts that we have delivered. So in case if you're going to request, we're going to also deliver the other concepts, which are turbo jet, turbofan and turboprop for your clarification with numerical parts as well. But let's see, if you are interested, we'll try to actually cover most of the sections, but obviously upon request and demand. So hope to see you with the comment section, with the demand as well, with the request. Else you can just go through the videos and get as maximum as possible from the solution part and also from the theoretical part as well. So hope to see you with some another interesting concepts in continuation with our channel, which is Introduction to Aerospace Engineering. And hopefully you enjoy that we are actually covering most of the topics, and also we're going to cover most of the topics on a continuous basis. And else you can visit our another channel, which is Nota Bene Tech on Tube as well. So hope to see you with our interesting concepts on engineering, interesting concepts on mathematics, interesting concepts from software point of view, so we can have as much possible as maximum. So I hope to see you with the continuation of the concepts. Till then, take care and have a nice day.